This is the file WB 5.1, and here we have the historic sales volumes for the Graves Beer Company, dating back to January of 1999. Let's first look at the behavior of that demand by creating a chart that shows the actuals. So we'll insert, and then we will choose a time series chart, and it will look like this. And we can change the values in the axle here. So let's select data, and here we can actually enter the periods that we are covering. So from January 99 to February of 2004. So that shows these values at the bottom. So this is our demand here. This is how the demand looks like historically. We will now use stat tools to create a forecast for this item. So we go to data set and create the new data set using all the data we have. So from January of 99 to February of 2004. And we can close this and move on into the time series and forecasting and select forecast. What we want to estimate is sales. We can then fill the rest of the chart by determining how many periods beyond February of 2004 we want to forecast. So let's stay with 1 for now. We can then choose the different methods here between moving averages, exponential smoothing. So if we select moving average, we can use a number of periods. So this is the 3-period moving average. We can do 4, we can do 3, we can do 1. If we use 1, will be the naive forecast. We can go into the 3 exponential smoothing options. Simple, the Holtz method that takes into consideration level and trend, and the Holtz-Winter method that takes into consideration level, trend, and seasonality. On the exponentially smoothing Winters Holtz, we have the 3 alternatives. When we move up to the Holtz option, which is just level and trend, we only have alpha and beta, and when we go to simple exponential smoothing, we only have the alpha to choose from. If we select optimize, then it will look at the best alternative. Here we have the time scale, and in this case the information we have is monthly. If we had it weekly, we will have 52 periods per year. If we had it quarterly, we'll have 4 periods per year, and so on. If we go back to the exponential smoothing Holtz, for example, and accept the conditions of optimized parameters, StatTools is going to look for the combination of alpha and beta that gives us the best MSE. And we obtain this result here that I'm going to expand for better visibility. So this is the forecast, and in here we have the metrics for it. So this is the mean absolute error. This is the root of the mean square error. So if we take this number to the square, we will see the MSE. And here is the mean absolute percentage error. We have the graph of the actuals in blue and the forecast in red. We go back to the data, and select the exponential smoothing with seasonality considerations. And in that case, we are able to see a much better match between the actuals and the forecast numbers, as we can see in this picture. And that is also reflected in the metrics.